Hey, this is Chapter 10, Part 3. We're going to do some math now. Most of your problems are going to involve a flow rate, a volume, and a time. We're going to have to be really careful with units because a lot of times we're going to have a mixture of hours and minutes. And we're going to have the drop factor and drops per milliliter, and often we're just going to start off with milliliters. We're going to have to be careful about that. On this problem, there is an order for normal saline. Just as an aside, normal saline is 0.9%. You also have half normal, which is 0.45%. Just divide that by 2. And we have quarter normal, which is 0.225%. Divide that by 4 and you've got that. That's an aside. We're supposed to infuse it for 8 hours. Find the flow rate, which is the pump setting, in milliliters per hour. The flow rate is the volume over time. So what they do is they took the volume, the entire amount of solution we're supposed to infuse, in 1,000 milliliters and divide that by 8 hours. We were supposed to do milliliters per hour, so our units are fine. Just do the division and you get 125. Okay. For this one, we have been ordered 1,000 milliliters of normal saline, and it's supposed to take 8 hours. The drop factor is 20 drops per milliliter. Find the flow rate in drops per minute. Okay, so we have milliliters, we need to get to drops, and we've got minutes. So and we've got hours right there. So we're going to have several conversions to do. Okay, so let's start off by saying we have 1,000 milliliters over 8 hours. Okay, I know I need to be in minutes, so let's go ahead and take care of that. I want to get rid of an hour, so I make sure it's on the diagonal, and that's now 60 minutes. Hours cancel out. Just do this math. You have 1,000. It's going to be 1,000 divided by 60 times 8 is 480. And we have milliliters per minute. And let's simplify that. And you get 25 over 12. And all I've done is reduce that fraction. Okay. So now I have milliliters per minute. I've got the minutes. I also want the drops. So now I'm going to use this here. So I have 25 milliliters in 12 minutes. And I need to try to get rid of milliliters. So this is 20 drops over milliliters, so I'm going to flip it for no I'm not. Sorry, 20 drops, and I want to get rid of milliliters. I want it on the bottom. These cancel out. 25 times 20 is 500 drops every 12 minutes. And if you do that division, you get approximately 41.67, and they want you'll round that to 42 drops per minute. Make sure that your units are correct. We were asked for drops per minute, and that's what we have. That should be our answer. And if you look at the next slide, that is exactly what they did. Okay? All right. So let's look at this one. The order is 775 milliliters of 5%. This is the dextrose solution, which we had the information for in a much earlier slide. And it was supposed to infuse over 6 hours. Initially, the flow rate was set at 26 drops per minute. But you go in 3 hours later, and the patient has received 500. At this rate, they're going to run out before they get to the 6 hours. So we need to recalculate the flow rate so that the infusion finishes on time. Now, this has a lot of information in there. What you need to realize is basically this is our problem. We need to figure out how much we have left and then we can use the 3 hours we have left because it was 6 hours total. We've used 3 hours. So we have 3 hours remaining. And then we need to do the same thing but with the amount of fluid we had. We started off with 775. We have used 500. So what we have is 275 milliliters left to go. Okay? So I'm going to take this and bring it over to this next slide. So right now we had this. We had 275 milliliters per hour. That's what we had left, so for 3 hours, and that's what we have from right here. We're supposed to go to drops per minute, and on this slide, the second, we were going to slow it down to 10 drops per milliliter. And that's from the previous slide. We're supposed to go to drops per minute. Okay, so we have 275 milliliters over 3 hours. I'm supposed to go to minutes, so let's go ahead and take care of that. 1 hour on the diagonal gives me 60 minutes. So this gives me 275 over 3 times 60 would be 180. So I have 275 milliliters over 180 minutes. Let's reduce that. And we get 55 milliliters in 36 minutes. Okay, so I've made progress. I have the minutes in the bottom. I need the drops, so here's where I'm going to use this. If I take this, and I multiply by this, my drops are going to be on the top and my milliliters are going to cancel out. Milliliters go. Multiply, you get 550 drops in 36 minutes. And go ahead and do that division. And you get approximately 15.28 drops per minute. And they're going to want you to simplify that or round it further to 15. The next slide shows us exactly how we did that.